Let's take a look at a quick application of the dot product. Again, thinking in terms of forces. So I have a box that's pulled 75 meters along a frictionless surface. Obviously, I don't know of any true frictionless surfaces, but we need this component, like I said, for what we're doing in this course. If this was a physics course, we take a look at coefficients of friction and how that would have an effect on this. But in terms of what we're going to be doing, we will always be working right now with a frictionless surface. So I have this box that's pulled 75 meters along a frictionless surface by a force of 35 newtons at a constant angle of 27 degrees. What is the amount of work that's actually done? So let's start off with drawing a picture here. So here's my box. And I'm pulling at this box with a force of force vector that is a magnitude of 35 newtons. And my displacement is my displacement vector, and that has a magnitude of 75 meters. And this angle here, theta equals 27 degrees. Now notice that 27 degrees is not a common angle, so I'm not going to be using radians. I'm going to stay with degrees here. Now, by definition, the work done is going to be F dot D. Now, F dot D is going to be the magnitude of F, which is 35 newtons, times the magnitude of the displacement vector, which is 75 meters, times cosine of the angle between them, so that's be times cosine of 27 degrees. Now, this is going to end up being approximately, and clearly this is a jump to your calculator and do this. We're not going to work with it any other way. And the calculator's going to tell me this is approximately 2338.8921. This 4 points to the right decimal, that's kind of a habit of mine. I tend to go 4 points for most places, or for most purposes. And the units here are going to be Newton meters. So the amount of work done is a scalar, and it has units of Newton meters. So roughly 2,339 Newton meters is a total amount of work that would be done by placing a force vector of 35 newtons at an angle of 27 degrees and pulling this thing for a distance of 75 meters.